Hello and welcome. Our focus today is on highlighting some of the new capabilities for communication protocols and functionality that comes with our latest 2023.4 software release. Let's dive in and explore how these changes can elevate your experience with Typhoon HIL. We are glad to bring you a new feature that will improve your flexibility when working with Modbus communication protocol. You can now select a specific HIL Ethernet port on the Network Settings tab of the Modbus device component. The number of available Ethernet ports will vary based on your hardware configuration. With this feature, you have greater control over your Modbus network specifications, allowing you to emulate multiple, distinct Modbus networks concurrently in different Ethernet ports. Furthermore, it's now possible to isolate the emulated networks entirely from the network that the PC uses to access the HIL device. Unified Diagnostic Services, or UDS, is a client-server protocol commonly used in the automotive industry. In the 2023.4 release, we've introduced a Python script designed to facilitate the use of the UDS protocol over CAN within our platform. This Python-based script, which can be easily deployed within the appropriate SCADA interface, shows how the integration can be done. For your convenience, this script, along with an in-depth explanation of some integrated features, is readily accessible in our comprehensive knowledge base. GPS time synchronization is now available for remote synchronization of the IEC 61850 sampled values protocol, which can be an important feature for the accurate simulation of merging units and an essential tool for testing modern digital substations. In our communication library, the sampled values folder under the IEC 61850 category contains all the necessary components for establishing this communication. To activate this feature, navigate to the SV Publisher mask, choose the ASDU tab, and set the synchronization mode to remote. Please note that GPS time synchronization depends upon the availability of a iRig-B port. Currently, this port is present in the HIL 604 and HIL 606 devices. Additionally, it's important to understand that when both PTP and GPS synchronization methods are active, PTP synchronization will take precedence. By introducing this feature, we are glad to offer enhanced capabilities in process bus testing. We are excited to introduce a new addition to our suite of communication protocols, Ethernet IP. As the Ethernet-based variant of the Common Industrial Protocols, CIP, Ethernet IP serves as a versatile protocol across various industries. In this release, we are providing a demo version of Ethernet IP support. To access this demo, navigate to the Typhoon HIL Control Center Examples Explorer. Under the Communication Protocols folder, you will find the CIP folder with a demonstration example. As the disclaimer shows in this example schematic, this initial version supports only implicit message transfer. It's important to note that for now, you must use the provided EDS configuration file when using Ethernet IP. This can be seen if you open the component mask. The EDS import button is grayed out at this moment, meaning you currently can't import custom EDS configuration files. Nonetheless, you can still edit parameters and enable the interfacing of these parameters with the model as the component input or output. However, looking ahead, we anticipate expanding these capabilities of Ethernet IP support in future software releases, enhancing the protocol's integration and flexibility within our platform. We are looking forward to hearing your feedback regarding this Ethernet IP demo. It's time to introduce the latest enhancements to the SFP simulation link components. This protocol utilizes a dedicated FPGA module, ensuring high bandwidth and low latency data exchanges between Typhoon HIL and other devices. In the Library Explorer, the SFP simulation link component can be accessed within the Communication folder, where you can find the following components: SFP Receive, SFP Send, and SFP Setup. The 2023.4 release introduces two significant improvements to the SFP Receive component. Firstly, A new feature in its mask is the high-speed checkbox. Checking it changes the mask interface, allowing you to select the number of variables to be received. These variables are then readily accessible through controlled voltage and current source components. The second upgrade for the SFP receive component relates to the variable configuration field. A new button has been added under it to facilitate the process of filling out this field. Clicking this button brings up a window where you can easily add and remove signals, as well as define their names, types, and dimensions. The SFP send component also received similar upgrades. Upon opening its mask, the high-speed SFP checkbox is immediately noticeable. Additionally, in the Data tab, you find the variable configuration field accompanied by a generated configuration button. The SFP setup component also has an improved capability to provide important debugging information. For instance, you can now add 2 extra outputs to this component. These are enabled via a new checkbox. The output terminal named header displays the latest correctly received header, while the header valid output terminal indicates the validity status of the received header via SFP. With these features, we aim to streamline how you use and set up SFP protocol by giving you more control over the variables and important debugging information. Now, let's have a look at some other upgrades and new components that will let you test more with your models. We are excited to highlight more enhancements to the HIL Connect Interface component we introduced the previous software version. We've integrated a checkbox that allows you to use the new Signal Chooser functionality. This checkbox can be found when configuring the settings of the card slots pin. This feature grants you access to the entire range of signals within your model, including electrical signals processed in the FPGA at smaller simulation steps, for instance, current and voltage measurements, machine encoders and resolvers, and PWM modulator signals. Prior to the 2023.4 release, sourcing FPGA-based signals to the HIL Connect interface was not possible without the use of signal processing components, which operate at their own sampling rates. In general, the measurement signals which is processed by the CPU is much slower than the FPGA-based signals, resulting in a downsampling of the signal. For this example, we have already added a PWM modulator component onto our schematic. The PWM modulator component is based on a dedicated hardware unit and operates at the device's clock frequency. In other words, this component produces PWM signals based on carrier signals generated by the FPGA. If we click on the plus sign, the PWM signal generated by the PWM component is selectable. Now these signals can be accessed via the HIL Connect device in their full resolution. We are thrilled to offer a way of sourcing every signal within your model, and we hope that with this improvement, the process of interfacing with external devices becomes even easier. To enhance the simulation fidelity of the behavior of switching devices, we introduced the capability to oversample the PWM GDS or PWM gate drive signals with a time resolution as high as 3.5 nanoseconds. Currently, we offer 2 oversampling options, the global GDS oversampling and the switch level GDS oversampling. While the global GDS oversampling is available for all converter models and often meets the needs, there are scenarios where multiple switching states change within a single simulation time step in the same standard processing core. To address this, we've introduced the switch-level GDS oversampling, which tackles the inherent limitation of the global method by capturing multiple switching state changes in a single simulation step per standard processing core. Previously, switch-level oversampling was exclusive to the single-leg IGBT component. However, with this update, we've expanded its applicability to our boost converter model. Upon opening the component's mask and navigating to the Advanced tab, you find the oversampling settings. Here, you can opt for either the global GDS oversampling or the switch-level GDS oversampling. It's important to notice that this feature is only visible with the device configuration of your HIL supports the setting required for switch-level GDS oversampling. This can be verified in the device configuration table. We are happy to expand this functionality to other components to accommodate more use cases where a higher frequency is deployed or a larger number of switching components are designed to operate in the same processing core. We are excited to introduce a new generic component to our components library, the bidirectional AC-DC converter. Our aim with generic components is to simplify and speed up the development of system-level applications. These generic components are equipped with a variety of functionalities and a set of essential parameters, all of which are configurable via the component's mask. Specifically, with the generic bidirectional AC-DC converter, you can quickly set different operational modes such as grid following, droop, or isochronous. The component comes with its own set of protection functions, for example, under or over voltage, as well as different types of grid code compliance, like low voltage ride-through. Additionally, this component comes with a user interface or UI that contains numerous probes and SCADA inputs. This ensures you have comprehensive control and monitoring capabilities over the converter's behavior. It's important to note the presence of the DC plus and DC minus inputs. These let you interface with any DC source you wish to experiment with, such as battery cell, fuel cell, and so on. If you want to experiment with this component as soon as possible, we encourage you to explore the built-in example we've incorporated into our Typhoon HIL Control Center examples dedicated to showcase this component in action. We hope this generic component will be instrumental in swiftly creating setups for studies that use the bidirectional AC-DC converter model. We are happy to have you join us for this comprehensive walkthrough of our latest release. Our upgrades are customer-driven, so we encourage you to explore these upgrades in our projects and share your feedback with us. For more information and updates, stay connected. Thanks for watching.
Check the video description for more resources on this topic, including how to download and get started with Typhoon HIL Control Center for free. You can also visit HIL.Academy to access free courses, expand your HIL testing skill set, and get certified. Subscribe to our channel to get notified about new content.